We are going to go through the problems from the topic 19 and 25 skills test. So the first question says the measure of angle ABC is 60 degrees. Find x. So we see two things to be true about the angle ABC. We see that the measure of the angle is 60 degrees, and we also see that the measure of the angle is 3x plus 15. So if I want to find x, I can set both of these measurements equal to each other and solve for x. So I'm going to write the equation 3x plus 15 equals 60. Then to solve for x, to get x by itself, first step is to undo addition, so I take away 15 from both sides. And that's going to give me 3x equals 45. And then I have to get rid of the 3, so I divide both sides by 3. And that gives me x equals 15. For example number 2, it also asks us to find x. Now in this case, notice that they give us a square in the bottom of the angle, and that tells me that my full angle has a measure of 90 degrees. Now what I know is that both of these angles are supplementary, since together they give me a 90-degree angle, so that means that if I take x plus 72, it's going to equal 90. Now this is a simple one-step equation that we have to solve for x. So to get x by itself, I take away 72 from both sides, and that's going to give me x equals 18. So my answer for x is just 18. Okay. Now our next example is kind of similar to the last one, but now we're looking at two supplementary angles. And I know they're supplementary because together they make a straight line. So when things are supplementary, we know that we can add them and set them equal to 180. So I'm going to take x plus 8, my first angle, and add it to 42. And together those are going to equal 180. Now before I can solve, I have to combine like terms. Anytime there's anything to simplify on one side of an equation or the other, we want to do that first. So I see some like terms, 8 and 42. When I add those together, it gives me 50. So then I have the equation x plus 50 equals 180. And from here, it's a simple one-step equation. To get rid of addition, I subtract. And I get the answer x equals 130. So that tells me that x is going to be 130. Now it's always good, especially when we have a variable that goes with a number for one of our angles, it's always good to plug back in x and make sure it works out. So if I plug in 130 for x, 130 plus 8 is going to give me 138. And 138 plus 42 gives me 180, so that shows me that I didn't make a mistake. Now the next question that we have is a different type of angle measures. Anytime we have two angles that are across from each other, created by two lines that are intersecting, we call those angles vertical angles. And we know that vertical angles are always going to be congruent. Now if they're congruent, that means we can set the measures equal to each other. So if one of the angles is 2x and the other one is 62, I can write this as the equation 2x equals 62. Now this is a simple one-step equation. To get x by itself, I divide both sides by 2, and that's going to give me x equals 62 divided by 2, 31. So x is going to be 31. And in this case, that does make sense because 2 times 31 would give me 62, and that would make both the angles equal to each other. Okay, for the next example, we're looking at we're going to be looking at our first picture where we have a transversal and two parallel lines. So this is saying find x. So I see that my two lines are parallel, and because they're parallel, I know that alternate interior angles, which would be angles like this, and corresponding angles are going to be congruent. In this case, we have corresponding angles, and I know that because they're both to the right of the parallel lines and both below the transversal. Same side of the transversal, same side of the parallel lines. So I know that I can set 10x equal to 70 because those angles have the same measure. To get x by itself, I divide both sides by 10, and I get as my answer x equals 7. Now if I want to double check my work, I can plug 7 back in for x, and 10 times 7 gives me 70, so I know that I didn't make a mistake. So the number 6 is very similar to number 5, but instead of looking at corresponding angles, we're looking at alternate interior angles. And I know that alternate interior angles are also congruent, just like corresponding angles. I know they're alternate interior because they're on the inside, the interior of the two parallel lines, and they're on opposite sides of the transversal. So I'm going to write my equation as 5x plus 12 equals 117, because I know both of those angles are the same. Now this is a two-step equation. To solve it, first I have to subtract 12 from both sides, and that's going to give me 5x equals 105, and then I'm going to divide both sides by 5. Excuse me, and that's going to give me 105 divided by 5, that'll be 21. So x equals 21. Now, especially with this one, I want to double check because I did a lot of work in this problem. So I'm going to plug x back in, 21 back in for x. So I'm going to take 5 times 21 plus 12. 5 times 21 gives me 105. And 105 plus 12 does give me 117 degrees, which is the same as this other angle measure, so I know I didn't make a mistake. Okay, number 7 is our first type of problem where we're trying to identify if the lines are parallel. So now we're looking at which of our angles are congruent and if we can tell they're parallel or not. Now let's go through our list to begin with and cross out anything that we know for sure isn't going to work. So the first set of angles is N and Q. Now what I see is that N and Q, they intersect at this point right here, and so I know that these are definitely not parallel. So that is not going to be a choice. Now P and Q, they kind of look parallel, so we're still going to check that to see if they will be. M and N also kind of look parallel, but we're going to check those to make sure they are. And then if we look at M and P, I know I can also cross out that choice because those are two lines that intersect at this point right here. Now to figure out if those lines are parallel or not, we want to look for our corresponding angles and also for alternate interior angles. So I see that with P and Q, I have two corresponding angles that are 103 and 101. Now the reason why I know that these are angles that go with lines P and Q is that if I were to draw in the angles right here, I see that P and Q end up being my two lines that kind of look parallel to each other. Now if we look at the angle measures though, for P and Q, our angles that are formed by the transversal in P and Q are 101 and 103. And so because they're not congruent, that shows me that those lines are not going to be parallel. Now if we look at the last one though, lines M and N, obviously those are going to be parallel because it's our only choice left. But if I were to look at lines, or at angles 103 and 103 and kind of draw those in, I can see that those angles are created by lines M and N and then also my transversal P. So that shows me that since they line up on M and N and both of those angles are congruent, M and N are going to be parallel lines. So M and N is going to be our sets of parallel lines. Our next example reads find x, and we have a triangle. I know that I have one right angle in our triangle because we have a square right here. That shows us it's a right angle, and then our other two angle measures are 70 and x. Now I know that my three interior angles in a triangle are going to add to 180. So what I'm going to do is just add up my three angles. I'm going to start with x. So I have x plus 70 plus 90 equals 180 because the sum of my three angle measures are 180. Now before I can solve this for x, I have some stuff to simplify on the left side. 70 plus 90 gives me 160. So I end up with x plus 160 equals 180, and then it's a simple one-step equation. To undo addition, I subtract, and that gives me x equals 20. So I see that my missing value, x, is 20, and that's my angle measure because it says x degrees. And to double check it, we want to make sure all of our angles add to 180. 20 plus 70 gives me 90, plus another 90 will give me 180 degrees, so I know that I didn't make a mistake. I have 2 more problems left. Now the next one, I know that I'm dealing with exterior angles here because angle 1, as we can see, comes off the side of one of the sides of the triangle. So the line was extended from a side of a triangle. And then the other thing that I see are 2 remote interior angles. I know those are the remote interior angles because they're not adjacent to angle 1, and they're both inside the triangle. Now one rule that we know is that our 2 remote interior angles add up to our exterior angle on the outside. So to find angle 1, I can take 63 plus 59. 63 plus 59 gives me 122 degrees, and so I know that the measure of angle 1 is going to be 122. Now for our very last question, we're going to be looking at triangle similarity. Now we know that for 2 triangles to be similar, 2 of their angles have to be congruent. And we're going to be looking at the bigger triangle, XYZ, and we're also looking at the smaller triangle, XTU. A lot of times when we have 2 figures within each other, sometimes it's nice to pull one of those out so that we can get a better idea of what angle measures we're looking at. So I'm going to redraw XYZ, our big triangle, and then also I'm going to redraw XTU. And I'm going to fill in the angle measures I know to begin with. So I know that x on both of these is going to be 103 degrees. I know that angle y is 45 degrees on the top figure, and I know that angle u is 32 degrees on the smaller triangle. Now so far we can see that one of our angles is the same, but we need to figure out that we have another angle in common. So we can choose either of our triangles to find the missing angle measure. I'm going to try to find the missing angle measure for, let's see, for the bottom triangle. So what I'm going to do, I know that my 3 angles in a triangle add up to 180, so I'm going to take 103 plus 32. That's going to give me 135 degrees. And then I'm going to take that away from 180 to find what the measure of angle T is going to be. 180 minus 135 gives me 45 degrees. And now what I can see is that I have 2 sets of congruent angles. Now if I wanted to, I could find angle Z, but I'm going to see that angle Z ends up being 32 by finding the missing angle measure in the triangle on figure XYZ. So just by having 2 sets of congruent angles, I can say yes, XYZ is similar to XTU. Remember that this sign, the squiggly line, means similar to.